Welcome to my channel CSE Concepts and Things. In this video, we are discussing about stack operations. In previous videos, we are discussing introduction of stacks and properties and applications of the stacks. We are completed discussing about last previous videos. In this video, particularly we are discussing stack operations only. If you ask any time stack based any question, at the time we are writing in first definition of the stack, first definition of the stack and principle of the stack, and conditions of the stacks, and next operations of the stack. Operations of the stack. So here one by one we are step by step written complete. Then we are entering to the stack operations. What is the stack? Stack is a linear data structure. What is the principle? LIFO. What is the stack? Linear data structure. Linear data structure principle LIFO. Conditions of the stack. What are the conditions? Underflow, comma, overflow. And operations of the stack. What are the operations of the stack? Push, pop, and peek. Next is empty, is full. These all are about operations of the stack. Majorly we are focusing on two operations. What are the two operations? Push and pop. Remaining three based on second level operations. What are the remaining three? PQ, is empty, is full. These operations are second level. First level operations are push and pop. If you ask anywhere, anytime, anybody, what are the major operations of the stack, we are discuss about majorly two things. The two things are push and pop. Let me see one by one. Push and pop. So this is the basic things. Push. First one, push operation. It returns add an element into the stack. This is enough of discussion about push. It returns add an element into the stack. Just only we are pushing to the element into the our stack. So that's why this is a simple discussion about adds an element. How to represent diagrammatically push operation? Diagrammatically push operation. This is our stack. 1, 2, 3. Now 3 elements are there. 1, 2, 3. Here we are push. This is the stack. Next, example of algorithm. This is the algorithm. Step by step. Start step 1. We are starting the procedure of pushing into our algorithm. Start, and second step will be if we are push an element in our stack, at that time we are check the condition. What is the condition? Underflow and overflow conditions are there. These are the conditions of the stack. So we are entering an element to the stack. At that time you check the condition if stack is space is available or not. If stack is empty, okay. If stack is full at the time, if you are entering the element at the time of stack is full, it will be overflowing, that is overflow occurring. So that's why we are writing conditions. If top equal to max minus 1, if top equal to max minus 1, then what happened? Top equal to max minus 1. Already stack is full, that's the top equal to max. So here, so observe second diagram. 1, 2, 3. 1, 2, 3, 0, 1, 2. This is our stack. Now, this is the top. How many elements are inserted to our stack? Only its size is 3. If you are insert more than 3, that will be overflowing. So this is max element. This is here max. Top equal to max. At the time stack is completely stored. So at that time we are inserted to the element 4. That will be overflowing automatically. That is writing the query here. If top equal to max, if top equal to max, then it will be stack is overflow. So at the time not possible to the inserting element into our stack. Okay. So next second top equal to max equal to 1. So then what happened? Stack is full. Stack is full. Otherwise is nothing but else part. What happened else? If your stack is full, insertion is not possible. Otherwise means another way. If stack is not full, it will be inserted to the element. So here pushing to the element into the stack. Into stack. If you are push an element, then what happened? Top will be changed. Now here in this stack, if you are available another place, at the time you are entering the element, it will be now before inserting the element, at the time this is the top. Then after pushing successfully completion of your stack, at the time top will be updated. What is this top? Top plus 1. Top plus 1. So here top equal to top plus 1. This is the simple information and algorithm about push operation. So next, second operation, pop. Let me discuss about pop operation. Pop operation. Pop operation. It returns, what happened here? It returns remove an element from the stack. So what is that simple description? It returns remove an element from the stack. Where we are removing? In that stack. We are removing from the stack elements. So at that time, diagrammatic representation of the pop operation. So now 3 elements are now 3. This is push. We are performing pop operation. Actually, how many elements are there? 4 elements. What is the top of the element? 4 is available in your stack. That is the top of the your stack. that element automatically removing when we are performing the push operation. So it will be removing. So I am writing that algorithm of pop operation. So algorithm first, step 1, start. Step 2, so removing process, first your conditions will be checked at the time of removing an element from the stack. What is the condition? Stack is elements are available or not. So what is that meaning? If your stack is underflowing, pop operation will be not possible. If you stack having some elements, at that time it will be possible to the deletion. So now this is empty stack. Stack is empty. Stack is empty. At the time is possible to removing an element from the stack? No. Because of stack is empty, at that time stack is underflowing. At the time of we are removing an element from the empty stack, condition will be occurred. Stack is underflowing. When it is possible, if a stack having some elements, at the time it is possible to removing or deletion from the stack. So in this stack is possible to removing, but in this stack not possible to deletion or removing an element. So if you take this one, so both are stacks. So that's why we are check the condition first. So that's why step 2, if top equal to -1. If top equal to -1, then what happen? So in this case, top equal to max -1. Here it will be top equal to -1. Because of stack is empty, and at that time where is top position in that stack? Bottom of the stack. That is we are representing as top equal to -1, stack is empty. So if top equal to minus, then what happens? Stack is empty. Stack is empty. Otherwise nothing but if stack is not empty, at the time stack having some element. So here else stack is not empty. So then what happened? At the time is possible to the pop element. So popped element from the stack. Then after completion of the popping operation from your stack, then what happened? Pop here, observe this is actually top position. After successfully completion of the pop operation, top will be decrease. What happened? Top will be decreased. If you successfully performing the push operation, top will be increased. At the time top equal to top plus 1. Here top equal to top minus 1. Now your top is after completion of successful pop operation, top minus 1. Now we are writing here top equal to top minus 1. So this is a simple algorithm about pop operation in that stack. So clear? So next operation, what is that next operation? Peak operation. Peak operation. It returns, what happening? It returns to find the top element of the stack. To find the, what happening? If you are using the peak function, it returns to find the top element of the stack. So that is a simple description about pop operation. Now let me see diagrammatically stack pop operation. First of all, we are check the condition. At the time of we are finding a pop element of the stack, in that stack having some elements, at that time is it possible to find the peak element, otherwise not possible because of stack is empty. Here in this diagram we are finding the top of the element, no, because of this stack is empty. So at that time it not possible to find the peak element or top element. When it is possible, if you stack having some elements, at that time it's possible to find the peak or top element. So this is the examples diagrammatic representation of the peak operation. So now algorithm. So what is algorithm? So step 1 start. Step 1 start. What is the start means? We are finding the peak operation in that stack. So at the time step 1 we are starting the procedure. Step 2. So at that time stack we are check the conditions, stack having elements or not. So that's why if top equal to -1, what is that? If the top equal to -1 means stack is empty. So at the time not possible. So stack is empty. Stack is empty. At the time it is not possible to finding the top of the element in our stack. Else if stack is empty, it is not possible to find the top of the element. Otherwise, if a stack is having some elements, this is empty, in this time not possible to finding the top of the element. Otherwise, stack having some element, going to the this diagram, stack having some elements, at that time is possible to top of the element. So now else stack is not empty first, stack is not empty, then stack top equal to element. So what is that? If top equal to -1 is nothing to stack is empty, at the time it's not possible to finding the top of the element. Otherwise, else what will be reflecting? Otherwise means it having some elements, at the time stack is not empty. So finding the top equal to element. Where we are top in the stack, what was the top of the element available in that stack, that will be finding to the this operation. So this is the simple description and algorithm steps and diagrams. And next operation we are performing. What is that next operation? Next one is the fourth operation. Fourth operation is that is full. Operation 4 is full. Is full. In it returns what happening? It returns to check the stack is full or not. Stack is full or not. It returns to check the stack is full or not. Just very simple. Now what is the conditions based on algorithm? Now I am writing algorithm of stack is full algorithm. Step 1. What happened in step 1? Starting the procedure. What is the procedure? To finding the stack is full or not. What is the procedure? So that's why step 1 start. Step 2. What happened here? Stack is full if top equal to equal to max minus 1. What happening here? See, observe diagrammatic representing. I am representing the diagrammatically. So, this is our stack present. So, here, 1, 2, 3, 4. This is the top element. Stack is full. Stack is full. So here it is the top element. So what that size of the stack max equal to max equal to 4. How many elements are maximum size of in that stack? 4 only. So already 4 elements are stored. At that time top element will be available top of the stack. So at that time we are trying to insert an element, stack is overflowing. What happening? Stack is overflowing. Already stack is full, but user can try to insert an element in that already full stack. Stack is overflowing. So that's why we are writing that here condition. If top equal to max minus 1, stack is full. Stack is full. Otherwise is nothing but else part will be executed. What happened? If you stack having some space, at the time stack is not full. Stack is not full. Stack is not full. So this is a simple discussion about is full operation in that stacks. So next operation to check the conditions. What is that? What is that next operation? So what is that next operation? Is empty. What is that? Is empty. Number 5 is empty. Is empty. It returns what happening? It returns to check the stack is empty or not. This is very simple. Stack is empty or not check at the time of we are using is empty operation. So what is that algorithm? I am representing algorithm about is empty. Step 1, start. What is the start? To find the procedure of your stack is empty or not. So first one, start. Step 2. So what is that? See, observe. Observe top equal to minus 1. Stack is empty. So second step, start. If stack is empty stack, at that time where is your top element? Top equal to top minus 1. So your stack is empty. Otherwise stack having some elements. So writing this query, if top equal to minus 1. Top equal to minus 1 means, see, observe this diagram. Bottom, below, these are the array 0, 1, 2, 3. For example, stack size is 4 elements, but in the stack also empty. So at that time, your top position is below 0. Below 0 value, your top position is available. So if top equal to minus 1, then what happens? Stack is empty. Otherwise stack is empty. Otherwise nothing but stack having some element. Here we are writing else stack is not empty. Stack is not empty. Okay, so this is the simple algorithm of is empty operation. So and one of the special operation is there, that one is stack size. What is that? Stack size, that is a special operation of stacks operation, how to represent the size. Sixth operation, size. So maximum there is no using in that operations of the stacks, but sometimes some cases it will be it will be useful. So what is that useful? If you find the how many elements in based on count based, how many elements are available in the stack, at that time we are using that stack operation. It returns to find the size of the stack. So very simple in query or syntax to stack dot size. So at the time it reflected to the how many elements are available in the stacks, that will be counted one by one. Then finally how many elements are stored in that stack, that size will be reflecting. For example, take this, after completion of operation we are finding the stack size. Here output is 3. So this is the simple operations about stack operations. సో ఈ వీడియోని ఫస్ట్ నుంచి లాస్ట్ వరకు చూస్తేనే మీకు క్లియర్గా అర్థమవుతుంది. సో మీకు ఈ కంటెంట్ నచ్చితే మీ ఫ్రెండ్స్కి షేర్ చేయండి, సబ్స్క్రైబ్ చేసుకోండి. సో థ్యాంక్ యూ.